This lesson deals with supplemental problem 15.2. You can find this problem in the ECE202 ebook in the Chapter 15 Supplemental Problems on page 3. Given this transformer with a primary inductance of 5 millihenries, a secondary inductance of 3 millihenries, and a mutual inductance of 2 millihenries, can you solve for the voltage V1 and V2 given the currents I1 and I2 as shown here? This particular definition of I1 and I2, I1 is entering the dot and I2 is leaving the dot. So in our formulas from the chapter, our mutual inductance will be negative. We have V1 is equal to L1 di1 dt, now minus M di2 dt. L1 is 5 millihenries, and then I1 is equal to minus 3 milli cosine omega t, where omega is 2 pi times 4 kilohertz. Now the derivative of cosine is minus sine, so I get rid of this extra minus sign here. And so I have 3 milli, and then I have the sine of omega t, and then the derivative of what's inside the brackets here, which is 2 pi times 4k. Then I have minus m was equal to 2 millihenries. And then we're going to take the derivative of this current, I2, which is 5 milli. Derivative of sine is cosine of the same frequency. And the derivative, what's in the brackets with respect to t, is just 2 pi times 2k. We can multiply all this out now, and we get our final expression then of this quantity multiplying the sine of 2 pi 4kt, which is 377 milli. And I have a minus, product of all this is 126 milli times the cosine of 2 pi times 2kt. And again, the units on here will be volts. And for the voltage V2 now, we have a minus M di1 dt plus L2 di2 dt. So we have a minus 2 milli, and then we have the derivative of I1, which was equal to minus 3 milli times the cosine of omega t. But again, the derivative of cosine is minus sine, so we get a plus sign here. And then the derivative of this bracket term with respect to t is 2 pi times 4k. And then we have L2, which is 3 millihenries. And then the current I2 was 5 milli times the sine of 2 pi 2kt, so the derivative of that is cosine, and the derivative with respect to t of this bracket is 2 pi times 2k. So you can multiply this out and we get a minus 150 milli times the sine of 2 pi 4kt, and then this all multiplied out is 188 milli times the cosine of 2 pi times 2kt. And this is supplemental problem 15.2.